Alrighty, in this video I'm going to go over how to add, subtract, multiply, and divide polynomials. So up until this point we've done a lot of exponent rules, and all the exponents that we've been multiplying and dividing together have been monomials, which means it's just one term with things multiplied together and another term with things multiplied together, but there have been no addition or subtraction of terms. So now we're going to learn how to deal with addition and subtraction. Fantastic. So adding and subtracting polynomials. So this is pretty simple. All you have to do is you've heard this before, it's called combine like terms. So when you're adding and subtracting polynomials, you can only combine terms that are alike. Okay, what does it mean to be a like term? It means that they have the same base and they have the same exponent, but their coefficient could be different. The coefficient is the number in front of the variable. So they have to have the same base and the same exponent. So here's a starting off good example. I'll get a different color here. So when we are combining like terms, we need to find all the terms that are alike. Okay, so here I have an x to the first power. Where else do I have x to the first power? I have some here, and I have some here. So I can combine all of these with these and these. So 3 plus 6 is 9, plus 1 more is 10. So I have 10x. So I've combined like terms. Anything with an x in it to the first power, I've combined. Now let me look at my numbers. I've got a 7 and a 1. So 7 plus 1, positive 7, positive 1, is plus 8. And lastly, I've got a positive 9a minus 4a. So these are like terms because they both have an a to the first power. Positive 9a minus 4a, 9 minus 4 is plus 5. And what is it? It's an a. So I like to think of these as like apples and bananas and fruits. I've got 3 xylophones, and I add 6 more xylophones, and then I add 1 more xylophone, so I have 10 xylophones. I have $8, and I add 1 more dollar. Sorry, I have $7, and I add 1 more dollar, so now I have $8. And A could be apples. If I have 9 apples, and I subtract or take away 4 apples, I now have 5 apples remaining. So make sure that you think of each quantity as only combinable with other things of the same type. For example, you cannot combine your xylophones and your apples. They are different objects. Okay. Now let's look at this one. Unfortunately, my notation is going to be a little bit weird. This little up arrow caret thing is going to mean exponent. Okay, so this is x to the third power. So where else do I have something with x to the third power? Okay, this is x squared. This has no x's at all. Aha! Here I have something x to the third power. Here I have x squared, and here I have a number. So x to the third shows up here, and it shows up here. Right here I have 1x to the third. And I'm subtracting 3 of them. What's 1 minus 3? 1 minus 3 is negative 2. And what is this thing that I'm subtracting? 3 of these from 1 of these. It is x to the third power. So the object that I'm adding and subtracting is x to the third, and the number of them that I have is 1 minus 3. Okay? If it helps, you can actually cross these out as you go. That way you don't accidentally use them twice. Okay, now let's look at our x squared. Okay, I've got x squared here, and I've got x squared here. I got 5 right here, and I'm adding 1 more. So 5 plus 1 is 6, and I have 6, and what are they? They are x squareds. So the object is an x squared, and I have 6 of them. I can't combine x cubed with x to the squared because they have a different exponent, even though they have the same base. In order to combine like terms, they must have the same base and the same exponent. That's really important. Okay, so now I'm done with my x squareds. Okay, the only thing left is just numerical values. I've got positive 6 and a negative 3. So 6, positive 6 minus 3. Add those together and you get, and you get plus 3. Okay, again, in all of these cases we are simplifying. We're not solving. Solving means like x equals something. Simplifying just means combine like terms, get it reduced as much as possible. So we are simplifying. Alright, let's take a look at the last example. Here I've got 5 apples, 5a. Do I have any other apples anywhere in this problem? 5 apples. Bananas, xylophones, dollars, Yeti, or Yiddish, or whatever you want this y to stand for. Anyway, you look through this whole thing, there's no apples anywhere else in the entire thing. So I have nothing that I can combine with this 5a. So it just stays as a 5a. It does not combine or simplify with anything. Let's move on to our b's. Here I have positive 6b. Scroll over, scroll over, scroll over. There's no other b's anywhere either. Okay, so plus 6b. So it's not always true that there's things to combine. Sometimes there's nothing to combine. 6b, 5a, nothing to combine. Now let's look at our x's. Okay, I've got a negative 3x here and a positive 3x here. What's negative 3x plus 3x? Okay, if I owe someone 3 xylophones and I have 3 xylophones, then I'm going to have to give all 3 to cancel out the 3 that I owe, and these two things cancel each other out. Just like negative 3 plus 3 is 0, negative 3x plus 3x is 0. You don't need to write plus 0, you just cancel them out. Alright, how about here? I've got a negative 7 and a negative 12. Okay, if I owe $7 and then I owe $12 more, then I owe $19. So anytime you're combining two things with the same sign, you just add them together and keep the sign. So negative 7 minus 12 is negative 19. Okay, those are done. The b's, we were done. The only thing left here is plus 5y. There's nothing else with a y in it, so I just toss on plus 5y, and that's my final answer. One thing I will say about notation is frequently you write these in alphabetical order. So you would write 5a plus 10x plus 8. This one you would write, actually this one is already in alphabetical order. Both alphabetical and from highest power to lowest power. So if you've got anything with different letters in it, put them in alphabetical, and then within the same letter, put them in the highest power down to the lowest power. So what would this one be? This one, a is good, b is good, so the 5a plus 6b, those would stay the same, but this, you put the numbers at the end also, I didn't say that. So 5y comes next, and minus 19. Okay, so again, when you're combining like terms, they have to have, using addition and subtraction, they have to have the same base and the same exponent, and then you just add or subtract however many you have, which is the coefficient. Okay, now we're going to move on to doing multiply polynomials. This is a little bit different, although you've seen it before, I think, when you learned how to do the distribution property. So when you multiply polynomials, really it's just the distribution property, although it can get a lot more complex as the polynomials get larger and larger. So you have to make sure that every term in each polynomial, so every term in the first polynomial, multiplies every term in the other polynomial. So if you just have two polynomials, everything in the first one has to multiply everything in the second one. And the way that you do that is distribution. So the 5 is the only thing in the first term, and the x plus 3 are two things in the second term. So this 5 needs to distribute and multiply both these. So you have 5 times x, that's 5x, plus 5 times 3, that's 15. So you should already have learned the distribution principle with one thing in the front and two things inside. Now, even if the stuff inside, there could be more than one thing inside, okay? And now we're going to try to take something outside and distribute it in. But you should always use PEMDAS to guide everything that you do throughout the whole year. So look inside those parentheses, and if you could combine the stuff in there first, you should simplify it and then distribute. So we could combine this x here with this here, and we could write this is actually 6x times 3x plus 1x is 4x, and 5 minus 7, 5 take away 7 is negative 2. Okay, and now we can distribute the 6x inside, distribute this inside. And when you multiply polynomials, you want to multiply the numbers by the numbers and the variables by the variables. You can only multiply things that are alike. I cannot mix the 6 and the x or something like that. So 6 times 4, number times number is 24, and x times x, those have the same base, so we add the exponent. X times x is x squared. Okay, so my first term times my first term gives me 24x squared. Then I throw in my minus sign. Now I'm going to distribute this 6x over to this 2. Okay, 6 times 2 is 12, number times number. Actually, let me make this minus sign more obvious. Minus. Okay, now 6x times 2. Let me say there's two ways to think about it. You could do 6x times negative 2 is negative 12, or you could think of this negative sign as being a negative sign, and then just look at 6 times 2. Either way, they give you the same thing. A positive and a negative is a negative. And then here I have an x. Here I don't have any x's at all, so I just have x to the first power. Think of this as x times 1, if you will. So 24x squared minus 12x. All right, let's look at this last one here. Here I've got a negative 3x squared, and inside parentheses I have a 3x, a negative 4, and a 2x squared. So even though I have three things in here, 1, 2, 3, and I've got a minus sign right there and a plus sign right there, none of these three terms are alike, so I cannot combine them ahead of time. So I'm going to have to distribute this in 1, 2, 3 different places. So let's look at the first one. I've got a negative 3 times 3. That's going to equal negative 9. Okay, and then I have x squared times x to the first power, so that's going to give me x to the third. So you can see our exponent rules are really important. It's good to have those mastered when we move on to this kind of problem. Now I've got a minus sign right here, so I put in my minus sign. Now I've got negative 3x squared times 4. Well, negative 3 times 4 is negative 12. And x squared times, there's no x's here, so it's just x squared. Okay, so because I had a negative times a negative, I end up with negative, negative, and that obviously becomes positive. Subtracting a negative is the same as positive. Finally, I have a plus sign, and then I have negative 3x squared times 2x squared. So again, numbers first. Negative 3 times 2 is negative 6, and x squared times x squared. You add the exponents and you get x to the fourth. So I would write this in order, we said before, alphabetical order and descending order. So this term would be first, negative 6x to the fourth, exponent 4, minus 9x cubed plus 12x squared. Okay, so that would be my final answer in reduced form. Fantastic. Now let's move on over here and look at binomials. So, let me go back. All of these was one thing multiplied by many things. So a monomial, one thing, multiplied by a polynomial with multiple stuff in it. And then you just distribute it in. So you've probably seen that before. But there's also a binomial times a binomial. So binomial times binomial means each term has two things in it. Bi means two. Think bicycle. So two things here, two things here. So when you're multiplying them together, you don't just distribute in the 3 here and here, you also distribute in the x here and here. So let me show you two ways to do this. One is called FOIL, which stands for first, outer, inner, and last. So first means take the first thing times the first thing. So here I'm going to have the first thing here is x, first thing here is an x. That's going to give me x squared. Outer means take the things on the outside. So the outside is here and here. Okay, x times 5 is 5x. Inner means take things on the inside. So that would be here and here. If you think of this as a sequence, right, the inside is the middle. So 3 times x is 3x. And the last is going to be the second guy here and the second guy here. So 3 times 5 is 15. And then these you want to add up because all these terms are added together. Okay, so the grand total is x squared. These two are alike, so I can combine those two together and I can make that an 8x. And the 15 has no like terms, so there's my final answer. Okay, so that's one way you can visualize doing this kind of problem. I want to show you a second way to visualize this kind of problem, which is using distribution, but in a little bit more complex way. So I'll put or, let me write it again, x plus 3, x plus 5. Okay, everything in the first term has to multiply by everything in the second term. So first we can distribute this x in. The x has to multiply towards both things. So x times x is x squared, and x times 5 is 5x. Okay, now the 3 also has to distribute in. 3 times x is 3x, and 3 times 5 is 15. And you can see that this whole thing gives you the exact same result. So you can do whichever one you're more comfortable with. It doesn't matter to me. They are both good. This one requires a little bit less space taken up, but first, inner, outer, last is a nice way to visually think about it. Remember though that first, inner, outer, last only works, FOIL only works for a binomial times a binomial. If this one has like 3 things in it or 4 things in it, then you're going to need more than just first, inner, outer, last because there's more combinations of terms. Okay, let's do one more example and then we will call it quits. Okay, so here's this example. I'm going to try doing it using this method of distribution. The 2x has to distribute to the x, and it also has to distribute to the 8. So 2x times x equals 2x squared. Okay, 2 times 1 is 2. X times x is x squared. Okay, 2x times positive 8 is plus 16x. Okay, 2 times 8 is 16, and I have x to the first power, and there's no x's here, so it just multiply by x. Okay, now let me do this one, distribute. Now I'm distributing a negative 3. Actually, let me make it red. I'm distributing a negative 3 here and here. And make sure you include this sign when you distribute. So negative 3 times x is negative 3x, and negative 3 times positive 8 is negative 24. Okay, let me kind of make a little separation between these two problems. And that was a little bit left over from before. So here we go. Now I've got a 2x squared. None of these terms have x squared, except the first one, so the 2x squared can't be combined. Okay, but these two I can combine because they are like terms. That means they have the same base and the same exponent. They both have x to the first power. 16x minus 3x. 16 minus 3 is 13, so 13x. And lastly, I've got a 24. It's a negative 24. Negative 24. There are no other numbers to combine it with. So that's my final answer. So when you're doing a binomial times a binomial, you can either use FOIL or you can use distribution. Okay? You'll see eventually problems that are actually polynomial times polynomial, but we'll get to those much later. So I hope this is a good example for both adding and subtracting polynomials as well as multiplying. And the last thing I'll say, let me get a little bit more space here, is if you want to divide polynomials, what do you do? What do you do to divide polynomials? We will learn about this later. So it's a little bit trickier when you're trying to divide polynomials. Let me show you what you can't do, just so that you can know now what not to do, although that hopefully won't mess you up at all. Let me give you an example. Suppose you have, that's not what I want. Suppose you have 2x plus 4 over x minus 8. Okay? You absolutely cannot just combine pieces with pieces. And the reason is, remember I said, anytime you have a fraction bar like this, separating the numerator from the denominator, it's just like you have this stuff in parentheses. Even though we don't draw them in, the stuff in the top is separate and the stuff in the bottom is separate, and there's these invisible parentheses, and you can't take just part of that and just part of that. It's this entire expression divided by this entire expression. So you can't just take pieces and pieces. So there's going to be other techniques we learn about later on in the year. But for now, if you had something like this, you would just say, I can't simplify it anymore. It's already in its most reduced form based on what I've learned. Okay? Alrighty, good luck on the problems.